Alright, last session, going to look at algebra today. This causes problems for a lot of people, but it's actually quite simple. Okay, let's get to it. I want you to consider first of all the following sum. 3 plus blank equals 7. You would have come across this sum in really grade 3, grade 4, early on in your math life, and very straightforwardly we can fill it in by saying that 3 plus 4 is 7. So the blank is equal to 4. Okay, we're happy with that so far. So the next question becomes, well, how do we prove that the blank is 4? What do we have to do to the 7 to get 4? Well, we're going to take away 3. But we also have to take away the 3 here. And that will give us that the blank is equal to 4. Okay, that's all that's going on here. A little bit of a history now for you on algebra. Algebra was created 2,000 years ago by an Arab named Algebra, which is where it gets its name from. It was used in the marketplace to exchange goods such as fruit. So if you can consider the scale that I've got here on the left, I've given the pineapple somewhat of a reprieve. We've got 3 pineapples on the left hand side and 8 bananas on the right hand side. So if you wanted to trade 8 bananas for 3 pineapples, it might balance, it might not, in which case you'd have to add another banana or take away a pineapple. But the principle of it was that the scale should balance. So that's where it came from. There is an argument that it's not used in everyday's life, and why should we bother even knowing about it? Well, that is true. I mean, you're not going to use algebra in day-to-day life and business, but it does underpin the kind of thinking that you need to have to reverse engineer problems. So thinking backwards is the right way of describing why it's useful. So here's another scale. We've got x plus 3 this time on the left equals 11 on the right. So I need to find out what this unknown is, x. Yeah, I should have said that rather than writing blank all the time, we write using letters or variables as they're known. Okay. So if I want to get the x on its own, I've got to get rid of this 3 that's on the left. So I'm going to do that by subtracting 3. And I've got to subtract 3 here. And that will give me, if I do the sum on the right, 11 take away 3 is 8. So those scales, that's the flash way of explaining what's going on. In reality, you're never going to see that drawn. You're just going to see stuff like this. And you need to know how to generate the answer x. In all of these cases, given what's there. So I have to look at this. If you imagine that this is the left-hand side of the scale, this is the right-hand side of the scale, I want to get x on its own. So to get rid of the 5 is what I need to do first. If I take away 5 and take away 5, 5 take away 5 will just leave the x on its own. And then 13 take away 5 will give 8. Next, x minus 3 equals 8. So I've got to subtract 3 next to this x. The opposite of subtract 3 would be add 3. And add 3. You'll find that the negative 3 and the plus 3 will cancel, leaving just the x here on the left. And then I've got 8 plus 3, 11. So that's add and subtract, or subtract and add. You do the opposite of what's there. Next, we're going to look at multiplication. So we've got 2x here, which means 2 times x. To get x on its own, I'm going to have to divide by 2. I can't just do it on the left-hand side, I've got to do it on the right-hand side as well. The 2's cancel, and I'm left with just x on the left. 24 over 2 is 12. Next we have divide. X divided by 4. So to get x on its own here, I'm going to times by 4. And that means I'm going to have to times by 4 here. The divide by 4 and times by 4 will cancel, leaving just x on the left. And now I have to do 16 times 4. So timesing something by 4 is the same as doubling something and then doubling again. What happened there? Let's see if I can correct that. There we go. So 16 times 2 is 32. Double it again gives me 64, which is my answer. I should have done that in black. Never mind. So then we've got to look at what happens when you've got minus signs in here, which is why I looked at the negative numbers last time. I've got 5 subtract x equals 13. If you'd like to have a go, please do. Otherwise, I'm just going to go through it. I need to get rid of this 5. So I'm going to subtract 5 on both sides. This will give me minus x equals 8. So notice I'm just getting rid of the 5 here. That negative x is still present. How do we deal with negative x? Well, I'm looking for positive x. How do I change from a negative number to a positive number? Well, consider the fact that this is 1x. There's only 1x there. And I've got minus 1 in front. If I then times this side by minus 1 and times this side by minus 1, because whatever I do on the left I've got to do on the right, minus times a minus will give me a positive, and 8 times minus 1 will be minus 8. I should have done that in black. That's our answer to this. So be careful with negative algebra. Again, you're probably never likely to see it in real life, but it's worth knowing about. Then we move on to two-step. So there's two things that are going to occur in two-step linear algebra. The first thing you're going to do is to try and get the 8. Get rid of that 8. So if I add 8 to both sides, the 2x that I've got here will fall down. 22 plus 8, 30. Now, I need to get x on its own. How do I get x on its own? Well, this is 2 times x. I need to divide by 2. Divide by 2. This gives me x equals 15. And that's your answer. So we call it two-step algebra because there are 2 steps going on. There's an addition and a subtraction step, which is usually done first, and then a multiplication or division step, which is done second. H squared O. Next one for you to try. Pause the video. Come back. Okay, going to solve this now. Subtract 9. Subtract 9. Three x. 27 take away 9 is 18. This means 3 times x. I'm going to divide by 3. Divide by 3. X equals 18 divided by 3, 6. Right, then we move on to 3 steps. And there are 4 terms here. So you've got x's and numbers. You have a choice here. You can either deal with the numbers first, or you can deal with the x's. So I think in this case I'm going to deal with the numbers first because it's going to make life a little bit simpler for you. Let us take away 6 on both sides. What's that going to give us? Well, 3x will drop down. (18) subtract 6, 12. Now, this is where things get a little bit confusing because some students would say, oh, you've got to take away 3x now. That will give you 3x on its own, and then you divide through to get your answer. It's not quite right. Remember on the scale, if I go back here to this, come on. What? No, I didn't want to do that. Yeah, here we go. Remember on the scale that the x was always going to be on one side and then the number would be on the other. I need to keep this 3x on its own on the left. Okay, so I'm going to delete that now, which means I have to subtract the 6x on the right. So this is going to make numbers slightly awkward. 3x take away 6x is negative 3x. Equals 12. Because now the 12 will drop down. Now I have to get x on its own. To do that, I'm dividing by negative 3. Dividing by negative 3. Negative 3's cancel. 12 divided by negative 3 Well, 12 divided by 3 would be 4. And remember, we've got a positive here divided by a negative, which will make a negative. Another example here, this time with more difficult numbers. So we can choose numbers or letters to start with. I'm going to choose numbers. So in the past I would have added 4 here. Or you may consider to add 4. It's actually the wrong thing to add. The correct thing to add is 20. Why? Well, by adding 20, you're going to not only get rid of the negative 20, but you're going to turn this negative 4 into a positive number by doing so. Let's have a look what this is going to give us. 2x minus 4 plus 20 will be plus 16 equals 6x. Now, the 6x is on its own on the right hand side. I'm going to leave that 6x alone. What I need to deal with is the 2x. If I get rid of 2x here and 2x here, this is going to generate 16 equals 4x. So you can have it with the number first and the algebra last. Same thing. It's just written back to front. And then I need to get x on its own. So I'm going to divide by 4 here. And divide by 4 here. This is going to give x equals 4. Or 4 equals x. It's the same thing. Multiplication, yes. So this is just some basic algebra as to what happens when you multiply things together. So if you take a number 2 and you times it by a, you're going to get 2a. Y times z will make yz. A times b times c will make abc. 3 times t times u will make 3tu squared. Okay? Because if you remember from the powers, when you multiply a letter together, the number of times you multiply it together will change the power of that letter. Okay, so if it was 3u's, you would have u cubed. But instead of spelling out all the multiplies, it's just 3tu squared. Similar thing with addition. So I've got c plus c plus c plus c plus c equals 5 times c equals 5c. So, I don't know, thinking veg here, carrots. If I have a carrot and I add 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 a carrot, I'm going to have a total of 5 carrots. That's what this is saying. Three F's will make 3F, and 4 Z's will make 4 times Z or 4Z. So multiplication can be represented by repeated addition. Division, the slash or over is used to represent division. So x over y is x divided by y, or x over y. Similar thing with numbers, 16 over 4, 16 divided by 4 will give you the answer of 4. Powers, again, I mentioned this briefly a second ago. Rules are for the same letters as they are for numbers. So I believe we did a little bit of this. 3 times 3 times 3 times 3 is equal to 3 to the power 4, because there are 4 3's there. And 3 to the power 4 is 81. The way you do that is saying, well, 3 times 3 is 9. 3 times 3 is 9. And 9 times 9, you should know, is 81. Letters, 5 f's together will make f to the power 5. 3 times h times h times I times I times I will give you 3h squared, because there's 2 h's. And there is 3 i's. So the number of i's that are multiplied together will give you the power. Brackets. So brackets can be used to change the order of operations. So hg plus f. If we remember Bodmus, that's the same as g times h, because you're multiplying the g and the h together and then adding f. But if we add brackets in there, so there's a bracket between the g and at the end of the f, you have to multiply out the h and the g, which will generate hg, and then multiply the h and the f, which will give you hf. Brackets can also be used with division, so a divided by b plus c will give you a fraction with the numerator as a and the denominator as b plus c. Coefficient, this is the last one that I'm going to cover. A coefficient is the number in front of a variable. So 2x, the coefficient is 2, because it's the number in front of the x. In 7h squared, the coefficient is 7. 4.2t, the coefficient is 4.2. 1/3 g, the coefficient is 1/3. And 1/3g, now this is a bit more tricky. What you've got there is a reciprocal of g. And 3 as well. So if I was to rewrite this very slightly, it would look like this. And then it would be 3 to the minus 1, g to the minus 1. So your coefficient there is 1/3 to the g to the minus 1. I've actually gone and shot myself in the foot here. What am I doing wrong? It should be obvious as to what that coefficient is. Why am I struggling? I don't know. Well, that is true what I've said there. No mathematician could argue against that. But I think the safest thing to say that the coefficient here is actually 3, because it's the number in front of the g, if that makes any sense. Although, technically speaking, what I've written there is also true, due to reciprocal laws. Right, that's it. I hope you've enjoyed it, and I'll catch up with you again